everyone, I'm Teacher Bojan from Kangaroo Study. Welcome back to our channel again. Now, today we are going to continue our Math Olympiad adventures by looking at this interesting topic. This is what we call the Pigeonhole principle. So, as the name suggests, this must have pigeons and holes. Everyone, you're right. So let's take a look at the first example question together. Now, in this question, we got 10 pigeons and 9 holes. They want us to show that there must be at least one hole with more than one pigeon. So first, let's get the 9 pigeon holes. Now where do we place the pigeons? Hey, everyone, how about this? Let's put 3 pigeons in each hole. So for the first row, we'll get 9 pigeons. Second row, we just need to add 1 more. And you'll notice that for all the holes in the first row, they already have more than 1 pigeon. Hey, we've satisfied the condition in the question. This is so easy. But this is not the correct way of solving the question, everyone. This is wrong. You know why? It's because of this word here, must. Just by having this random case, it works. Can we ensure that it works for all the other cases? No. We do not know for all the other cases whether it works or not. So what should we do now? So everyone, let me tell you. There's one special case. If this works, all the others will work. This is what we call the worst case. So you can consider it this way. If the worst thing can happen here, the worst case already works. The others are the better cases. Of course, they are going to work. So now the question is, how do we find the worst case? Now, question wants us to have more than 1 pigeon in a hole. So we notice the worst can happen is we do not have more than 1 pigeon in a hole. So this way, what's the most number of pigeon we can put in one hole? Very good. We can put at most 1 pigeon in a hole. So let's do that now. Right? First hole, put 1 pigeon. Second, put 1. We do the same for the others. All the way to the end. Do we satisfy the condition yet? Not yet. They want us to get more than 1 pigeon in a hole. But right now, it's only 1 pigeon. But do we have all the pigeons here? We notice this is not all the pigeons. Right now, we only have 9. But in the question, we got 10. So where do we put the last pigeon? Everyone, can we see that for the last pigeon, no matter where we put it, for that hole, we'll always get 2 pigeons. No matter where we place the last pigeon, that hole always get 2 pigeons. So we've successfully solved the question. So now, let us take a look at the summary in this question. Now, when the number of atoms is more than the number of containers, in this case, the atoms are the pigeons, and the containers are the pigeonholes. When this is the case, this question we got 10 pigeons, 9 pigeonholes. 10 is greater than 9. If this happens, after we put 1 pigeon in each hole, there will be some pigeons left. So those pigeons will go to some of the pigeonholes. Those particular pigeonholes will have more than 1 pigeon. So we always have 1 container that have more than 1 atom. Now after knowing this, let's take a look at the second example question. Now in a class of 13 students, show that at least 2 of them will have their birthday in the same month. Let's think. In this question, we don't have pigeons or pigeonholes. Can we still solve it using the same method? So first, let's get the so-called pigeons here. The so-called pigeons will be the students. Now how about the so-called pigeonholes? We have to put the birthdays of the students into the different months. So we notice those 12 months here, they are acting as the pigeonholes. This is the 12th month. So let's get the 12th month first. From January all the way to December. The next thing we need to consider. Can we just choose a random case here? Definitely cannot. Just last question, we already did that. That's wrong. So we must make sure that this always happens. Because of the word must, we have to consider the worst case. So what's the worst case here? Question wants us to have 2 students in 1 month. The worst can happen is we do not have 2 students in 1 month. So we know we can put 1 student each month. Let's do that now. January, 1 student. February, 1 student. We do the same for all the others, all the way until December. So now, do we have all the students? No, we only have 12 students now. In the question, we have 13 students. There's still 1 more student. Now, where do we put the last student? You notice, the last student, no matter where we put it, that month have 2 students. So we have solved the question again. So now, let's look at the summary. In this question, again, with the number of items is more than the number of containers. Or in this question, the items are the 12 students, the 13 students, and the containers are the 12 months. Now, since the number of students is more than the number of months, there will always be one month with more than one student, or one container with more than one item. Now, in this question, there's one more step. We have to identify the pigeons and the pigeonholes. After that, we can apply the pigeonhole principle. So now, let's move on to the next question. This will be the real challenge for the day. Now, this was from 2024 GP round 2. It's a real question from the test. So let's see, from the numbers 1, 2, 3, 4, 5, and 6. Is it possible to choose any 4 of the numbers? So there will always be 2 numbers. The sum is 7. If yes, explain why. If no, give us an example of 4 numbers that doesn't work. So in this question, what's the pigeons? This one is also not the pigeons or the pigeonholes. So we gotta identify the pigeons and the pigeonholes first. So the so-called pigeons are the 4 numbers we select. We select 4 numbers from here. But how about pigeonholes? This one we are not so sure. We are given 6 numbers, but 4 is less than 6. So what are the pigeonholes? Let's look at what the question is asking us. This question asks us, the sum of the 2 numbers must be 7. So let's figure out what are the numbers that add up to 7. If the sum equal to 7, we can have 1 and 6. What else, everyone? Very good. We got 2 and 5 and 3 and 4. You'll notice that these 3 groups of numbers, the 4 numbers, 4 is greater than 3. The items is greater than the containers. So this means that the pigeonholes here is the 3 groups. 4 is greater than 3, then we can apply the principle. So now we must consider the same thing. This must be the worst case. So what's the worst case here? The worst case is we select numbers from different groups. Because if you select 2 numbers from the same group, immediately the sum of them is already 7. So let's do the worst case. Choose a number from the first group. Then we choose a different number from the second group. Then we choose a number from the third group. Now right now we got 3 numbers. How about the last number we can choose? You notice the last number will fall in any of the groups, and that group already got a number. So no matter where we place the last number, for that group we will always get 2 numbers. Now once the group have 2 numbers, the sum of them add up to 7. So we solve the question again. The answer is yes. This is always possible. Because for the 3 groups, there will always be a group with 2 numbers, and those 2 numbers add up to 7. So now, let's do the summary for this question. So in this question, the most difficult part is finding the pigeonholes. Now, how do we find the pigeonholes? First, of course, we have to identify the pigeons. So we know this. From this question, we can see the pigeons, it can be the numbers, or it can be the people, or it can be objects. Now, after we identify the pigeons, the next thing is we can check what the question is asking us. We find the goal in the question. In this question, the goal is to get 2 numbers where the sum equal to 7. So the next thing is, according to this goal, we can group the numbers, or we get the groupings. So those numbers add up to 7, 1, 6, 2 and 5, 3 and 4. From there, we'll know that these different groups are the pigeonholes. And then we can solve the question using the principle. Now, after we understand this, let's have this practice question. It's very similar to the question just now. So once you figure out the answer, you can post it in the comment section, or else you can add my contact here, so we can discuss the solutions together. Now, if you want to get more information about the math trainings and GP preparation materials from our center, make sure to join our study groups here. So once again, I'll see you next time. Peace out.